Hello everyone, myself Dr. Vijaykumar, Associate Professor, Department of Electronics and Communication Engineering, Aditya University. In this session, we are going to see the operations on multiple random variables. So at the end of this particular session, the learning outcome we will be learning is we will be seeing the different set of operations we can perform on multiple random variables. So there are different operations we can perform on multiple random variables, joint moments about the origin, joint moments about the mean. So moments about the origin we have studied mn, we denote with mn, and moments about the mean we denote with mu n. Here we study for two-dimensional, it will be extended as mnk, here it will be mu nk. Earlier the order is n, here the order will be n plus k is the order. That's the only difference between the single dimensional random variable and two-dimensional random variable. So everything is extended for two dimension. Here the order is expressed in n, here it is n plus k. So the mathematical formula for joint moments about the origin is expectation of x power n y power k. So if it is a continuous random variable, so this is the formula. So when n is equal to 0, k is equal to 0, m 0, 0, its value is equal to 1. When n is equal to 0, k is equal to 1, m 0, 1, it is nothing but expectation of y. When n is equal to 1, when k is equal to 0, its value is m1, 0, it is expectation of x. When n is equal to 1, k is equal to 1, order is 2, m1, 1, it is expectation of xy. This we call it as joint expectation, or sometimes we call it as specifically correlation. Correlation is a measure of similarity between two random variables. If two random variables are correlated, so its correlation coefficient will be 1. And similarly, other significant orders are m20, which gives you the mean square value or average power of x, m02, mean square value of y, average power of y, and m11 already we have seen correlation, very important factor. So the correlation is m11 is equal to expectation of xy. This is for continuous random variable, this is for discrete random variable. It measures the similarity or strength or direct relationship between two random variables. So there are different properties we use for solving the problems. Correlation, rxy is equal to u of xy, and if the random variables are independent random variables, it can be expressed as e of xy is equal to u of x into e of y. If the random variables are of orthogonal random variables, its correlation value is 0. Next fundamental operation we perform on multiple random variables is joint moments about the mean. Here also the formula is extended to two-dimensional. Earlier it is expectation of x minus x bar whole power n, now expectation of x bar whole power n into y minus y bar whole power k. Computing, this is the formula we use for continuous random variable. Here also for different cases we are seeing n plus k is equal to 0. 0th order, its value is 1. 0 plus 1, first order, again we will get 0, 1 plus 0, first order, its value is mathematically equal to 1. N plus k is equal to 0, its mathematical value is expectation of constant is constant, expectation of 1 is 1. Next mu11, this is of significance, mu11 is also called as covariance, where there m11 is correlation, mu11 is covariance. So covariance, this is the formula for continuous random variable and this is the formula for discrete random variable. Covariance also got few properties. Covariance and correlation can be related as Cxy is equal to Rxy minus x bar into y bar. Covariance means expectation of x minus x bar into y minus y bar. If you simplify this, what we will get? Expectation of xy minus x bar into y bar. So this is the covariance alternate formula by reducing, simplifying the expression. And when two random variables are independent, its covariance is 0. And variance of x plus y can be expressed as variance of x plus variance of y plus 2 into cxy. If they are independent, this part will vanish. If they are dependent, covariance will exist. So in joint moments about the origin, the important parameter is correlation. In joint moments about the mean, the important parameter is covariance, along with joint expectation, marginal expectation of x, marginal expectation of y, along with variance, all those things. And additional things which we observed in two-dimensional random variables is correlation and covariance. And there is one more parameter called correlation coefficient. Based on this value, I can tell how much X and Y are correlated. The strength of correlation we can tell. If it is equal to 1, they are 100% correlated. If it is equal to -1 also, they are 100% correlated. If rho is equal to 0, that means there is no correlation between them. So, the mathematical formula for rho is mu11 by root of mu02 into mu20. Mu11 is nothing but covariance of xy. Mu02 is sigma y square. Mu20 means sigma x square. Square root will give you the standard deviation of x and standard deviation of y. Here, the value of correlation coefficient decides the amount of correlation. So, let us see one problem, how to compute the covariance for a continuous random variable. So, the continuous random variable, the density function is given to us. And the covariance formula is E of xy minus E of x into E of y. We know the E of xy formula, xy into fxy of xy dx dy. Solving this, we will get 1 by 2. Similarly, E of x and E of y. E of x is also mathematically represented as m10. So, this can be computed like this, and similarly m01 represents E of y. So, the covariance is -1 by 36. Given two random variables x and y having the moments given to us, now we need to compute mu22. Mu22 means E of x minus x bar whole square, y minus y bar whole square. So, this here m22, sorry, this is m22, E of x minus x bar x, E of x square into y square. Since they are independent, this can be written as E of x square into E of y square. And E of x square and E of y square can be computed from the variance and mean values. We know that variance is equal to E of x square minus E of x whole square. From this E of x square we can compute. Similarly, E of y square. So, computing these values and substituting here, we will get m22 as 60. And this is the problem related to computing all the third order moments. So, what are the third order moments? Third order moments depends on the value of nk. N plus k should be equal to 3. 2, 1, 1, 2, 3, 0, 0, 3. So, the 4 combinations we need to compute. M30, M03, next M21, M12. Different combinations we need to compute based on the order value. So, in this session what we have seen is, we have seen the operations on random variables. The operations on random variables, joint moments and moments about the mean. In joint moments, one significant observation we made is correlation. Moments about the mean, one significant observation we made is covariance. And the correlation coefficient relates the covariance. Based on the correlation coefficient, we can measure the strength or correlation between the two random variables. So, in the next session, we will start the problems on random process. We will reintroduce, already we have seen the definition of random process and classification. So, we will see the problems related to random process, problems on stationarity, problems on ergodicity, problems on correlation, cross correlation. Okay, thank you.